so I'm really excited to hear from our next presenter. I think we've met in passing at Aruba Atmosphere or something like that, but we didn't really have a chance to talk, and we've been in the back talking for a little while now. And really fascinating guy. He's got experience with two-way radios. He's got experience in the world of cellular, and of course in Wi-Fi. And we also both have our CompTIA Security Plus. I don't run into people that have Security Plus around here very often, so that's kind of cool. But I'd like to welcome to the stage Jose Velez. Jose.
Thank you, Joel.
Hey, Jose, I noticed that your MacBook has real USB ports. It's kind of nice. Right? I haven't had real USB ports on my MacBook in a while now, so.
There you go.
Yeah, it's really
Nice
useful.
time.
So yeah,
Thank you.
but I want to catch up later when you're done. Have fun.
Excellent. Thank you, Joel. Good evening. So that was a very good introduction by Joel, so thank you for that. And a little bit of my background. So I began my career at Motorola Solutions about 10, 11 years ago. Right out of college, they hired me on to this group. We used to be called the Wireless Broadband. So within that team, we did everything from wireless LAN, point-to-point, point-to-multipoint, microwave, you name it. And we also got involved a little bit into cellular technology. So I was with them for about 7 years or so. And then I took a job with Charles Schwab, the financial company, specifically to do Wi-Fi. And I've been with them for about 4 years or so. And so that's my background. And the agenda for today, it's going to be focused on 5G. So when we talk about 5G, right, we think about, well, that's a new technology that just came out, if you will. And we hear about how is that going to coexist with Wi-Fi. So we need to consider, or we need to understand, how those two technologies coexist and how they behave when they coexist in the same environment. So I'll be touching on figures of merit of 5G. I'll touch briefly on the spectrum. Then I also mentioned about the third generation partnership project releases. Then we talk about some medium access control mechanisms that are implemented in cellular and also in Wi-Fi. And then I will just leave the session with some coexisting considerations. So before we start, I wanted to have my opening statement, if you will. And it's basically this, right? I don't believe that cellular will replace Wi-Fi. And I do not expect Wi-Fi to replace cellular technologies. And the same argument was happening maybe 7 years ago or so, maybe 10, about, hey guys, is cellular technology going to replace two-way radio for mission-critical communications? Any two-way radio guys here in the audience? Got a few there. Very good. So you are probably familiar with the argument. Hey, why do we need two-way radios? We can just use a cell phone, right, for public safety. Well, the answer is no, we cannot do it, right? And here's the reason why. The reason is because each of these technologies have their specific purposes. And with that, they have to meet a specific confidentiality, integrity, and availability requirements. So with that in mind, let's talk about the releases. So the third generation partnership project, and this is specifically to LTE. So you think about back in 2008, we began with basic LTE. Then we went into these LTE advanced about 2011, 2010. Then we migrated all the way to LTE Advanced Pro. And now we're talking about NR, which new radio, 5G. So 2019, release 15. Now we also have release 16. And I just give you a screen capture from the actual release notes from the 3GPP website. So release 15 is basically, I want to say, hand in hand with release 16. Release 15 is phase 1 of 5G NR. Release 16 is phase 2. And today, if you go to their website, you also see that release 17 is under content review, content approval. So what is 5G? Right? So it's the 5th generation of cellular technologies. So 5G NR, new radio, is advancement of LTE into this new radio technology. So similar to what we have seen in Wi-Fi, right? We went all the way from BG, we got N, right, AC, AX. And what we've done in Wi-Fi is we have taken what we've learned, right, from the past, make it better, more effective, more efficient, and now we have AX. Similar situation with LTE. Now we're taking LTE, what we know from it, and we're going to take it to the next level, which is 5G NR. Now, with this technology, also came the implementation of what we call the LAA, or Licensed Assisted Access. So LAA allows to coexist Wi-Fi and cellular. And this happened, why? Because we're going to be using unlicensed bands. Now, there's you want to call it a philosophical argument. Is that good? Is that bad? We're going to get into it, and I would like to hear from you as well. Also, with these 5G NR, right, the purpose is to allow for ubiquitous cellular coverage, right, and take advantage of this spectrum now that we now have access to in the, in the 5 gigahertz band. So release 15. This is an extremely condensed list. If you go to the actual website, it's like a whole laundry list of features. I don't want to do that to you guys as the last presentation, so I just wanted to pick on the most important parameters as they relate to Wi-Fi. So 5G system, basically phase 1 with release 15. We're going to talk about wireless LAN and unlicensed spectrum use, has additional improvements for LTE, and also allows for this logical end-to-end connectivity. So going back to this topic of coexistence. So why coexistence, right? We cannot avoid the deployment of cellular devices, right, into our spectrum. So we need to understand at least what's going on in the background. Why and how are these technologies being deployed in our space, right? Because 5G, I mean, if you ask me, 5 gigahertz band is Wi-Fi. That's just my personal opinion. So why are they coming into my background, right? Why they want to, out of deciding you guys from the cellular world, come to my space? Well, there's a reason why, and that's why we need to talk about coexistence. So this screen capture came from the actual 3GPP website, and release 13 actually has the spectrum defined, which all of you guys know is 5 gigahertz. It's exactly the same as what we use in Wi-Fi. So Unit 1, 2, Unit 1, Unit 2, 2A, we got the new band there mentioned. So it's the same. Therefore, as Wi-Fi engineers, we need to at least understand what's going on. We need to understand how is our spectrum going to be used. And we also need to understand or be familiar with what are the medium access mechanisms when we have 5G and Wi-Fi. So let's start with this first technology as it has to do with medium access control. And it's what we call CSAT, or carrier-sensitive adaptive transmissions. So what is the purpose of this technology? It's a medium access technology. The purpose is to allow for effective and fair coexistence of LTE with Wi-Fi. Now, this came about in, I believe it was, release 11 thereabouts, so 2012 thereabouts. So it was one of the first mechanisms, if you will, for allow for these Wi-Fi and cellular coexistence. And something of note that I wanted to share with you guys is that there is no regulatory requirement for what we call listen before talk mechanisms in certain countries. One of them is the US. So because there is no such a requirement, then we don't have to abide by these listen before talk, which is just a fancy term to say, hey, listen before talk, what is it? Fancy term to say, hey, you need to do physical carrier sensing and virtual carrier sensing. That's just the fancy name or the abbreviation, what we call in the cellular world, listen before talk. So it's very important, and also CSAT allows for these small cell deployments, mainly to do data offload. That's one of the main purposes. And something important about these CSAT is that it's the way that they sense the channel is heavily influenced by this channel duty cycle. So that's one of the parameters that are used to do channel sensing. They look at the duty cycle of a channel. And also, they want to use a carrier aggregation for supplemental downlink. And as you may know, right, the algorithms, these algorithms right here, allows for these adaptive time division multiplexing of transmissions to LTE small cells. So time progressed, right, from the CSAT dates. Now we're going to talk about LAA. So this is the key part, if you will, of my presentation, because this technology, it's, I want to say for all practical purposes, is the same as what we're used to in Wi-Fi. So the same purposes, right? Effective and fair coexistence. That's the key reason behind LAA. It came about in the release 13 of LTE, and again, it implements a listen before talk algorithms. And then something that's important is with this LAA mechanism, right? We can have what we call the secondary cells transmit in unlicensed channels. But here's the catch. So you can do the the downlink, right? The supplemental downlink in the unlicensed band, but guess what? The primary cell carries their high priority control traffic. So they say, look, we're not going to mess with unlicensed because we want to make sure that our control traffic is still maintained and preserved, right? So we're going to keep that in a licensed band, in a licensed channel. Is that good or bad? We're going to get into it in a little bit. So very important. And also, one of the goals of LAA was, hey, guys, we as cellular providers, we want to make sure that as we compete, we also have similar performance. So that was another requirement, if you will, or figure of merit for LAA. A few more items about that. Again, we talked about listen before talk. Very important. It also implements DFS. As you may imagine, for 5 gigahertz, they also implement DFS. And they also implement something that's called maximum transmit time duration, DTX, as well. And as we talked about earlier, listen before talk senses the channel before transmitting on that channel, so we're familiar with that. It performs energy detection, so that will be your physical carrier sense. And it also implements the random backoff that we're familiar with. So I wanted just to throw this little chart out there just to show you guys, most of you are familiar with how we access the medium in Wi-Fi, but perhaps you're new to Wi-Fi, so just to give you an idea of how this works, right? So to start off, we do the physical and the virtual carrier sense, right? If that's good, then we look at the medium. Is the RF medium busy? Yes or no? How is the network allocation vector, right? Is it greater than 0? Then we do that. Then we check we select the random backoff value, right? We look at that. Is it greater than 0? Is it greater than 0? No, then transmit. If not, we continue this cycle. So it's a very polite protocol. And again, some of you guys, I want to say most of you are very familiar with Wi-Fi, but perhaps some of you are new to it. So the way that you would describe Wi-Fi when talking with a cellular guy or with a two-way radio guy is Wi-Fi is a very polite protocol. Why? Because we listen before we talk. We do this carrier sensing. We understand, how the medium is behaving, right? We have these thresholds, right? So very important. So now let's talk about CSAT. So CSAT, it's, I want to say, a little bit different, and perhaps the argument about, hey, is it fair for cellular to use the unlicensed spectrum, right? Are they taking advantage of us, if you will, right? Are they utilizing the spectrum or more time space than we are? Well, I believe the argument can be made for CSAT, perhaps. So let's go through the way that they access the medium, right? So the first thing they do is they do this channel selection. And again, this is based on physical carrier sensing. Then we check the channel. Is the channel clear? Do we have a clear channel? If we do not have a clear channel, right, we implement the CSAT algorithm. If we do, we use the channel completely, and we go from there. Now, between the time that we check the CSAT and the full duty cycle of the channel, right, when we utilize it, as that's going on in the background, we also check, hey, is the cell site, what is the utilization of the cell site? Is it low? Is it high? And based on that, we utilize the unlicensed spectrum. So if the load is low, then we're not gonna use it, right? Because if there's not much load on the cell site, therefore we're not going to use unlicensed channels, right? But if it is, right, we will. So that's basically the gist of it. of CSAT. So I wanted to share with you also how this works, right? So how does CSAT implement this mechanism? So they basically take chunks of the same channel, right? LTE is going to be on for a little bit, and then Wi-Fi will come on. And that cycle will continue on. And again, it's based on their carrier sensing, if you will, their physical carrier sensing based on a channel duty cycle. So CSAT allows for scheduled LTE U meaning unlicensed, and Wi-Fi transmissions on the same channel. That's very important. So here's the, the philosophical question, if you will, that I wanted to, hear from you guys, once we get to the questions later on. So to reiterate the item that I mentioned earlier, is that under LAA, secondary cells can transmit in these unlicensed bands, right? But with the assistance of a primary cell that operates on a licensed channel. So when I was thinking about this, I was thinking, well, you basically get the best of both worlds. And then I came to the thought of, well, look, let's talk about air fairness, right? That's very important. So what about controlled traffic air fairness? Is that fair? Think about it. If I'm going to keep my controlled traffic in a licensed band, I can basically guarantee, because it's a licensed spectrum, that that's going to happen. My controlled traffic is going to go through, it's going to work, but everything else that I don't care about, I'm going to use unlicensed. I'm going to infringe. I mean, again, I know it's unlicensed band, but I feel like the 5G is Wi-Fi. That's just how I feel about it. We're going to use, this guy's spectrum for traffic offload. Now, is that fair? You tell me. But that's what's going on, right? So again, their controlled traffic, their high priority, it's still licensed, but everything else, if you will, the offload is unlicensed. Again, is that fair? If they're going to use our spectrum, I know it's not our spectrum, I keep on saying that, it's not, but if you're going to go unlicensed, just go all the way, man. That sounds reasonable. It's like guys saying, look, guys, we're going to use 700 megahertz for our controlled traffic in Wi-Fi. What do you think they will do about that? You think they like that? If we just tell them, hey, we're going to use all our beacons are going to go in 700 megahertz licensed, and all the user traffic is going to go unlicensed. Will they like that? I don't know. But anyway, something to think about. I wanted to share that with you. Again, it could be debated, if you will. But nonetheless, I wanted to share that with you guys, so you guys can make your own conclusions. So some recommendations. It's very important to understand the release that cellular technology is working on. I know here in the US, we're still talking about, 5G and R is fairly new, but most deployments are LTE-U, right? LTE Advanced Pro, still out there. We still have some basic LTE. We still have some 4G. So it's very diverse in the US. Now, if you go to South America, right, it's different. There are a few generations behind us. So we need to understand, again, that yes, the releases that these cellular operators are operating on, it's important, it matters, because it's going to tell us, okay, what mechanism for you to access the medium it's going to be used. So it's important to understand that. And with that, right, is a CSAT, LAA, and those are hard conversations to have because some of the people selling you a DAS system may not know that. Right? And they may have to put engineering resources and talk to you about that. And that's something that happened to me. I was, working for a project. It wasn't a brand new building, but it was a green cellular technology building, if you will, right? So we wanted to have cellular in this building. So the way they do it nowadays is they don't put a new cell tower for you, right? That makes no sense for them. But some companies will go in and deploy a DAS system, a distributed adaptive system antenna system, and distribute the cellular technology inside the building. You can see it here probably. And so you need to ask, hey, are you going to use LAA, CSAT? Are you guys going to use anything like this at all? Is it going to be all cellular? Is it going to be Wi-Fi? So it's important for us as Wi-Fi engineers to understand this at least, so we can have those conversations. We also need to understand that some cellular infrastructure devices, as I believe Keith showed us, they look like APs. I don't know if you guys have. Anybody has seen those cellular devices indoors? DAS systems? Anybody? You have over there? Very good. So yeah, they look like APs, basically. Maybe a little bigger than an AP, but they look like an access point. And what I've learned is that these devices, they come with Wi-Fi integrated in the same box, if you will. And do they turn it off? We don't know. So again, I wanted to bring that up so you're aware that, hey, it's cellular for sure, but it may have integrated Wi-Fi, and guess what? They might leave it on, and they don't even know about it. So again, good for us to understand that, good for us to know that that's out there, so I wanted to share that with you. And I mentioned that, so that's very important. So especially for those of us that have growing companies, if you will, companies that are growing, expanding. You go into a brand new building, they're going to deploy a DAS system, they're going to deploy Wi-Fi. It's important to understand, right, what's going on. Very important, again, with DAS systems. And something that it's familiar to us is physical separation. And physical separation is important because of harmonics. So you might say, well, look, they're operating in, 2.5. We're operating in 5 gigahertz. It's not going to affect us. It might. The question is, the point is that it might, because harmonics do matter. And what are harmonics, right? So when you have a signal and that signal mixes, you have this ripple effect, right? Albeit not as high as the main carrier, but nonetheless, the ripples can be strong enough that can interfere with your access points, right? And remember, our trigger for Wi-Fi, what is it? It's about -82. Right? If you do a physical carrier sense and you sense about -82 dBm, you're going to stop. You're going to detect it. So again, harmonics are important, especially when they're mounted very close. And I've seen that. I've seen sometimes an access point right here and the DAS equipment right next to it almost. So we don't want to do that. So just be aware that harmonics do matter, right? Channel planning. So that's a basic item to check. Why? Because remember, they're going to bring another equipment that operates on our spectrum to our environment. So if your channel planning is poor to start with, by adding another transmitter, it's going to affect your performance. So solid channel planning up front is great, and it can help you improve these coexistence mechanisms. Spectrum analysis, very important. Why? Because that will allow you to know what's in your environment, noise floor, right? So very important always to have a good spectrum analysis performed prior to deploying anything. So with that, I just wanted to share with you guys some resources. I know I've been talking a lot about the third generation partnership project. So their website is a very good resource. I would encourage you, if you want to learn more about LTE, about LAA, CSAT, that's a good resource. So you can access all the releases. So very good website. There's also a very good paper that I found by Qualcomm. It talks about LAA, CSAT is very good paper on LTE unlicensed coexistence. Very good paper, highly recommended. So with that, I want to say thank you for your time and open it up for questions.
All right. Thank you, Jose. Any questions? Yeah, let's give him a round of applause. That was excellent. Yeah. Let's see. We'll get to the text-based questions here in a second, but Eric's got a question real fast.
Hey, my question is about the CSAT. Is it a 20 megahertz channel? You referred to channels. What is it, a wideband, narrowband, or?
That's a good question. So based on the literature that I read, I've seen it in 40 and 20 megahertz. Yes, sir. And actually, they've done a lot of simulations. So let me just, we have a few more minutes, just telling myself, if you will. Prior to really digging into this coexistence issue, I came in thinking, LTE is bad for Wi-Fi. That was just my personal view. I said, look, it's terrible. But the more I read research on it, papers, the conclusion is it's not really. It's not any worse than you adding an extra AP to your environment, if you will. Try to understand what I'm saying. It's not as worse as adding more, another AP to your environment. Is that good or bad? It can impact your throughput for sure, but it's not like it's going to make it go down the tubes. It's not like that. There's plenty of algorithms, research simulations that say that no, it's not what I thought, if you will, because I came in thinking that it's going to be terrible for Wi-Fi, but it's not. So that's, again, you can you can go to those resources that I shared with you and take a peek at it. So yes, to answer your question, absolutely, 20 and 40, that's what I've seen.
So we got a few questions up on the board up here. So LAA only listens to energy detect and has no idea what an 802.11 frame is. Is that good enough?
I think that's a good question, right? Because LAA has energy detection, but remember, it also does virtual carrier sensing. So I believe it is good enough because remember, it does the same thing that we do in Wi-Fi. So we do carrier sensing, right? We do the physical carrier sense. We listen for RF signals. And then we also do the virtual carrier sensing, which is how we implement the backup timers, the network allocation vector, things like that. So yes, I want to say, in my opinion, right, it is good enough for LAA. Very specific question for LAA, so yes.
So if I allow LAA to be turned on at my campus, how can I tell if it's negatively affecting my Wi-Fi? Any tools?
So remember, LAA transmits in our spectrum. So you will see it because it's going to be in your channels. So I would say your typical RF tool will show that. Now, is it going to negatively impact your Wi-Fi? I want to say no. I mean, it's just going to be an extra device transmitting in your environment. So remember what I talked about, physical separation? So if you want to minimize that impact, if they're going to put the DAS right here, then your AP should be, I would say, minimum 30, 40 feet of physical separation. And if you implement that, I want to say no, you shouldn't see any significant impact on your network.
Is LAA just for cellular DAS or small cells too? Macro sites?
It's for small sites. That's the blanket answer, if you will. It's for small sites.
Yeah, thanks. I want to ask, are there some tools you could recommend? I mean, layer 1 and layer 2. I'm thinking about some things like, I mean, say I mean, how would you even tell if it was like CSAT versus LAA for the deployment? I mean, you could ask them, but would there be a way for some tool, for example, to check something like that?
That's an excellent question. I am not aware of any tool that would tell you that. But what I could tell you is from my experience is you will have to talk to the vendor about it, and they will tell you and give information about how is that going to implement. But to answer your question, no, I'm not aware of any tools that will. I'm sure there are some, but I'm not aware of anyone. But if any one of you guys know that, please share it with us. But I'm just not aware of it. I'm sure there are.
Any other questions? Okay. Jose, thank you very much.